Journey, a smart travel planner that organizes your itineraries and keeps you updated throughout your adventure. The registration process is quite straightforward. Firebase is used to handle the authentication process, and thus there's better performance and reliable security. The user can set its default preferences by navigating the settings screen. You can select a start time and an end time that fits best for your schedule. Now, the travel plan for the day will be restricted within these hours. You can update these default preferences for your personal trade, so the system can learn you better when creating the itinerary best suited for you. To create a new itinerary, simply search for a destination that you would like to go. Now, the application will display the best lively places that you can enjoy. Once you have a pick, click the Create Itinerary button to plan a trip considering the nearby places to it. First, select a preferred date range. Now, you can choose if you want to create an itinerary for personal or for a group. To invite your friends, add the email addresses of the friends with who you like to travel with. Our system will measure all the preferences and create an itinerary that suits the whole party. Finally, the system will prompt you with your default preferences. Now, you can decide if you like to make an exception. Let's say you want this trip to be more relaxing, and if you make this change, this will affect only this item.
Understand our high level architecture of our journey system. So we have here presentation layer, and in the backend we have two services, database services and the search services. So we have a Nginx reverse proxy. So all these are containerized in separate containers, and based on the routing, uh, the each services will be used. And here we are using strategy design pattern. So here we are using a rule based approach. So if you want to develop this system into a more intelligent way, if you want kind of a machine learning recommendation model, so it will be easier to plug that into this system using this strategy method. See how our strategy works. So as I mentioned earlier, we are using a role-based approach. So this is our workflow or our pipeline. So initially we are getting some places and we are filtering those places based on some parameters, and we are calculating the distance to those places from our origin, and we are ranking those things and finally getting our out. So this is how we um getting the nearby places, where we getting the initial places. So in Google Maps we have nearby search API. So basically we are this is our origin, and we are defining a radius based on the number of days of the trip. And the tourist attraction places I have mentioned in this URI here, tourist attraction places uh, will be returned to the system, which are inside this radius, which are included in this circle. So that's the basic concept that we are using here. uh, so after getting those places, we have to filter those things. So in Google Maps API we will get some places which are not suitable for our system, such as the travel agencies and some stores, some restaurant, because we are not focusing on restaurant this product, we are more focusing on the places. So we have to remove those things. So in this filter by type method, we are removing those places. And I have to mention something, that here you can see some keywords as well. So based on the user's preferences, for if he a nature lover, these keyword will be used uh, for getting the nearby places. And keywords are uh, we can put those keywords here, and we are looking through all the keywords and we are getting the whole bunch of places, and then we are filtering those places. So this is how we are calculating the distance from origin to particular places. So we are looking through all the places and we are getting the distance here. So here we have considered the surface curveness of the earth as well, but it won't matter much, but we have implemented that as well. So this is the main function, the ranking function. So we are considering the distance from origin, which we calculated earlier, and we are also considering the rating of that particular place and the number of rating. So based on these three parameters, and after normalizing these values, we are giving a separate weight for these values 0.5, 0.3, and 0.2, and based on those values we are sorting, and based on those values we are getting the rank, and we are sorting all our dictionary based on that rank. So this is our ranking mechanism. So then the final routing mechanism where we are using the direction API of Google, and here it's kind of circuit, because our strategy is to use a circuit. This is the origin place and as well as the destination, same place. So after the journey we are returning back to the same place. So it is kind of much easier to develop the system. So based on the previous ranking mechanism, and as well as the we are using this optimized waypoint true as our kind of its parameter, query parameters. So then the Google Maps API also will suggest us some optimal path to go our trip based on our places. So this is basically our main plan, how we build the system.
You can view the generated itinerary as shown categorized to each day. As mentioned earlier, each circuit lies within a single day, so the traveling distance is minimal. If you admire the itinerary that we have created for you, directly click the Save button to add it to your list. Click the View button if you want to glimpse more about that destination. If you like to take an action on this itinerary, click the Activate button to commit to the travel plan. Once this is done, the system will keep an eye on this itinerary and suggest dynamic changes through our mobile application. You can also reverse this decision by deactivating the trip. Initially, the generated itinerary goes to the inactive state right after the user saved it. Then, as we saw earlier, it can switch on back between the active state based on the user input. Both these states can be changed if the end date is reached. The incompatible state indicates the ineligibility of moving to the active state, as there is no operating period for the user to enact on the trip. The user can simply fix this issue by resetting the dates. There are two possible state transitions for the to-be-reviewed state. In a rare case, the user can deactivate the trip and continue the life cycle through the incompatible state. Or, the user can post a review and end the cycle. If you want to search all your trips, navigate to My Itineraries. All the itineraries that are not in the review state are cached in the front-end web application, as they need users' attention. Therefore, these travel plans can be searched hastily. However, as the user accounts get mature, it makes more sense to have the reviewed itineraries in the backend, since they are not accessed frequently and occupy undesirable storage. Hence, a backend call is made when the user requests to search for a reviewed travel plan. Additionally, the user can filter the search further by specifying either or both the date range and a keyword. In this state, the user can either deactivate the trip and restart it, or post a review on the quality of the itinerary. This review aids in measuring the success of mapping the preferences to the generated list of destinations. As we gain more data, we can improve the system to support a machine learning algorithm. We have given the functionality to the user if he wishes to remove the itinerary at any state. However, you should be careful as you cannot retrieve back.
This is the Journey mobile app. User can use mobile app after registering from the website. This is the login page, which is the first page is shown when user opens the app. User can log in with the email and password of Google. After that, user can see this travel itinerary. User can skip the screen to see day-by-day plan. And also, user can touch a card and be aware of this.